Welcome everyone to Smart Health Talk Radio Show. I'm your host Elaine McFadden, and I just want to thank you so much for joining us here on KCA Radio Smart Health Talk. And I'm especially excited because we have one incredible guest today. And I'm going to tell you a little bit about him, and there's a lot to tell here, so just bear with me. First, I want to welcome Dr. Shiva Ayyadurai, who's on the phone here waiting to talk to us. He's an inventor of email and an MIT systems scientist. He's been a prolific inventor and scientist since the age of 14 years old, when he invented the first email system while working at a medical school in Newark, New Jersey. He went on to get the first copyright for email officially recognized, and he named it email. So we have him to thank. He went on to MIT and received 4 degrees, a bachelor's in electrical engineering and computer science, 2 master's degrees, one in theoretical mechanics and another in visual studies from the Media Lab. Next, a PhD from MIT in biological engineering and systems biology. And we're going to be talking a lot about that today. His most recent invention is cytosol, which is a technology that allows one to model complex molecular pathways and biological phenomena on the computer. Now, cytosol, it can be used to create new pharmaceuticals, new functional foods, and new therapeutics without the need to kill animals. Is that great? Most recently, cytosol was used to discover a drug for multi-combination therapy for pancreatic cancer, which has been allowed for use by the FDA and is now going to clinical trials. Very exciting. Cytosol was the technology used to show that genetically modified organisms do disrupt the molecular pathway of plants, and most importantly, Dr. Ayyadurai's research has shown that there is no standards for assessing the safety of GMOs. So that's a big deal for me. And I can't wait to talk more about this. And he's got something going on that's pretty big too. So you're going to want to stick around and find out what that is. So I want to welcome Dr. Ayyadurai, and I would like to ask him, where he wants to start telling us about his incredible life, and about the latest efforts to get safety standards applied to genetically modified food.
Yeah, so let me give you a little bit of a background. I'll do a couple of things. Let me give you a background on my motivation and even getting involved in medicine and health and science.
Okay.
Then I'm going to give a little bit of a background on the technology that we built at MIT, which lets us really understand what's going on not only with GMOs, but all sorts of very complex phenomenon at the molecular level. And then I'm going to talk about what the research we did on GMOs in particular, what our research showed, and why we're challenging Monsanto now. Okay. So I think that'll give, your viewers a real capability to understand what's really going on. So first of all, I grew up in India. I grew up in Bombay, but I also grew up in a small village where my grandmother was a traditional healer. And I saw her heal people using traditional systems of Indian medicine, and this was by the time when I was 3 to 6 years old, and that's why I was very motivated to understand how this woman with no degrees was able to heal people. That really inspired my interest in medicine.
That would inspire me too.
Yeah, so my grandmother was a poor village farmer, but on weekends her doorstep would be lined up with people, and she helped them. We moved to the United States in 1970, so I was very motivated to understand how my grandmother was able to do this. So I excelled in school, academically, also athletically. By the time I was 14, I had finished calculus, all my math courses, and I went on actually to MIT, to New York University in a special program in computer science when I was only 14 years old. Graduated top of the class, and although I was still in high school, I ended up getting a full-time job at a medical school, initially doing research on babies who were dying in their sleep, known as SIDS. And while I was there, I actually invented the first email system, as I mentioned. And that's where I really learned about systems. You see, email was the electronic version of the inner office mail system, inbox, outbox, folders. And I, in fact, got the first U.S. copyright for email. In fact, named it email, which was never the term never used before. But I'm the inventor of email, even though some
That's incredible.
people, yeah, even though when the news came out after the Smithsonian, the military attempted to take credit for it when the facts were completely against them, but they created controversy when there was none. So after that, I went on to MIT. I did 4 degrees across multiple fields of engineering and science, and my PhDs in biological engineering. And in 2003, I returned to MIT to do my research on cellular systems. And that's when I created a technology called CytoSolve, C-Y-T-O-S-O-L-V-E, cyto meaning cell, solve meaning solving the cell. And using CytoSolve, we were actually able to use the computer to understand complex ways that the body functions, what goes on at the cellular level. You see, today, when we create an airplane, we don't just kill test pilots. The entire airplane is created on the computer. It's modeled perfectly. And then we do wind tunnel testing, and then we go build it. The way that we do creation of pharmaceuticals or therapeutics, we literally kill a lot of animals, and we actually hurt humans. So with CytoSolve, we're going to be able to use a computer to create new medicines. And in fact, several years ago, we used CytoSolve to actually create and discover a new medicine for pancreatic cancer by using combinations of drugs, which got allowed by the FDA. And now we're working with MD Anderson, the most prestigious cancer clinic in the world, to take it to clinical trials. So CytoSolve is not some theoretical tool. It's a real capability.
It's like a simulation, correct?
Yeah, but the simulation is based on actual wet lab research. It's more of an integration. It's not a simulation, it's an integration.
Okay.
So what we're doing is, in biological research, what happens now is it's like the blind man observing the elephant. Every blind man sees parts of the elephant and they don't know what the other is seeing. Well, in biological research, individual biologists, if they're trying to understand cancer, they're looking at parts of the cell or parts of different functions. They don't integrate it together. CytoSolve looks at their research, their actual research, takes those results, which are how the molecules interact, and connects it together. So it's not just a model. It's an integrative system which lets you integrate actual research that scientists have conducted. That's why it's CytoSolve.
This is like one of the most exciting things to happen to medicine probably ever, in my mind.
Yeah, if email was the electronic version of the interoffice mail system, all the inbox, outbox, all those connections, CytoSolve's the electronic version of the human molecular cellular system. That's what it is. And we've done it on the computer so we can save lives, we can save time, we can save money. So we've published many papers. We've been quoted in Nature. We've published in Cell's Biophysical Journal. You know, we have relationships with major universities, including Harvard, who's using us for research on ALS, as well as SMA, MD Anderson on pancreatic cancer. So this is the state-of-the-art tool. If email was a revolution in communication, CytoSolve is a revolution in medicine.
And the potential to save lives, bottom line.
Potential to save lives and to accelerate the discovery of cures. Now, for me, I got involved in genetically modified foods in a very interesting way. 2 years ago, on the front page of MIT Technology Journal, which is the most eminent technology journal, which I appeared on the front page many years ago for another company. I did EchoMail. MIT's Technology Journal, in the January 2014 issue, had a big front page article which said, "Buy fresh, buy GMOs." And this concerned me. Why was MIT actually advertising GMOs, declaratively saying it was safe? So what we did was we used CytoSolve. I mean, we did this really as a corporate social responsibility project. We used CytoSolve to literally, and we looked at really understanding the claim that Monsanto makes today is 2 claims. One is that the genetically modified version of what they create is no different than the non-genetically modified version. That means if they create genetically modified corn, they're saying it's materially the same as a non-genetically modified corn.
Something I could never believe.
Right. If they say they created genetically modified soy, it's the same as a non-genetically modified soy. In fact, 94% of the soy in the United States is genetically modified. The other claim they make is that when you eat this, it's not going to hurt your body. So those are their two pillars of their claims. The first one, called material difference or substantial equivalence, that the non-GMO is the same as the GMO, is used as the basis in the United States in a self-regulated way for allowing that GMO crop to be given to the public. So right now, if Monsanto, when they created the Roundup Ready soy, the GMO soy, all they needed to do was to show that the GMO soy was not materially different to the non-GMO soy. Well, how do they do that?
Yeah, that was my next question. How did they do that?
So they choose criteria. So it's regulated by the manufacturer. So if Monsanto says we're going to check the nutritional value, carbohydrates, fat content, protein, the color, for example, and if they compare those with the non-GMO and they show they're the same, then plus or minus 20%, then they simply let the FDA know they've done this material difference testing. And the FDA actually has no say in allowing or not allowing GMOs. They just do what's called a quote-unquote safety consultation, and they give them a letter. And the letter says, "Dear Monsanto," and I'm sort of paraphrasing the template letter that they get, "Thank you for doing the testing. You state you have done the testing," you meaning Monsanto. "You state that there are no material difference and that really the responsibility is on you. But because you say you've done the testing, we're fine with it being allowed to go to the public." That's it.
And we're talking millions of people eating it on a daily basis.
Right. So the point is that the issue is, how did they do that safety testing, e.g., how do they determine the material difference, is based on criteria that they choose. Okay? So that's the point here that everyone needs to understand. So this is no different than if you went to the Department of Motor Vehicles and you're trying to get your inspection sticker, and you told them, let's say for emissions, "Hey, I did the emission testing in my home, and I find out based on the criteria that I've set that the emission's okay." And the Department of Motor Vehicle says, "Thank you, Shiva, thank you, Elaine, for doing the testing. You can take the car on the road," because their whole mode of allowing the car on the road is just based on you saying you did it. Okay? This is probably the most important point everyone needs to. Mainstream media hasn't gotten this right. In fact, the anti-GMO activists haven't gotten this right, neither of the pro-GMO. Everyone's confused this very fundamental issue. There is no standards for safety testing of GMOs. It is all based on self-reporting. I'll repeat that. There's no standards for safety testing of GMOs, all based on self-reporting. In fact, the GMO salmon, if everyone reads, it says that the company determined that it was nutritionally equivalent. The company determined it. How do they determine it? They probably established their own criteria. Well, the fat content, the protein content was the same, therefore it's safe. Okay? So what we did, we actually did science. We actually went and did science. And what did we do? Well, every scientific organism, your body, a plant, a bacteria, any animal, is literally a walking, breathing chemical factory. Right now, you have millions of proteins and molecules in your body that are interacting, that define you. A woman, for example, is different than a man based on the fact that a woman has certain chromosomes, XY chromosome for a man, a woman has XX. So if you go down to the molecular level, you can actually establish objective criteria. What makes, let's say, a woman different than a man? Okay? What makes an ant different than a cockroach? There are molecular fundamental reasons. However, if you randomly said that we're going to use a criteria of does a woman and a man have hair, do they both have two eyes, and do they both have a nose to determine gender, you'd say a male is equivalent to a female. right? It would be absurd because you're not using any science or what are called objective criteria. So when we did this research, so that's the background. So we wanted to find, can you establish criteria for really understanding the difference between a GMO and a non-GMO? Like scientific criteria, not stuff that you make up so you can convince people that the GMO is the same as a non-GMO. Like, what are the criteria?
Well, and with the technology we have today, you would think that should be possible.
Right, but the issue is you have to do a systems analysis, okay?
And that's what you specialize in.
That's what we do.
Thinking about systems so that we're actually getting it down to a precise measurement.
Well,
scientifically.
Systems thinking means you look at the whole, okay?
Okay.
So if you go back to the example of the blind man and the elephant, you know, you had individual people who were blind. One guy was looking at the elephant's ears and he thought it was a fan. Another guy was looking at the tail and he thought it was a brush. Another guy felt the four legs and he thought they were tree trunks. And another guy felt the body and he thought was a wall. Now, if you took each of those people's advice, you know, and you put it together, you would come up with not an elephant. You'd probably come up with a picture of a wall standing on tree trunks, waving with a fan and a spike and a brush, okay? Systems thinking says you got to look at the interconnections. How are things interconnected? Because when you look at not the parts, but the interconnections, then you can understand the whole. Okay, that's systems thinking.
And one reaction is influencing another reaction as well, and there can be a cascade of reactions that happen when you change even one small thing. And I think that was something you said in your paper which really hit home with me. And that's what I believed all along, and that's why we've had this show all this time trying to get that point across. I'm so grateful to have found someone that can articulate all of this in the way that you do, because I think we just need to get what you are trying to explain to us across, and we need to just keep saying it over and over again and explaining this to everybody else out there in this format. So why don't you go ahead and
what we did was we wrote a series of 4 scientific papers which were peer-reviewed and they were published. What we wanted to understand is what is the difference between a non-GMO and a GMO, and how would you establish that difference scientifically, okay? So in paper 1, we went through 11,200 plus papers to find out, are there certain molecular mechanisms common to all plants? And we found out there's a metabolic mechanism called capital C1 metabolism. What is that? To put it simply, it's how plants create carbon, right? Photosynthesis occurs and plants create carbon. C1 metabolism, think about it as a big engine that the plant has. That engine is composed of 3 major parts. One part is called methionine biosynthesis. You don't need to understand the details. Methylation, and another part is called formaldehyde detoxification. So you can think of them as 3 different gears which are working together for this thing called C1 metabolism. Within each of those gears, there's even more molecular systems. So for example, the methylation process creates formaldehyde. Okay, so all plants actually are creating formaldehyde, which is a known carcinogen. However, plants are very smart. They have a formaldehyde detoxification sub-engine, which takes the formaldehyde and detoxifies it using a chemical called glutathione. If you look up glutathione, it's one of the most important antioxidants that occur in nature. So plants do create formaldehyde, and then they detoxify it. Okay, so we found in those 11,000 papers, we were able to connect these papers when we found the molecular mechanisms, all the different gears involved in C1 metabolism. That we published in a journal called Agricultural Sciences. In fact, my research team did it, but we also did a very cool thing. We worked with 4 high school students and their teacher in my old alma mater high school, Livingston High School in Livingston, New Jersey. And these students were the best of the best AP chemistry students. And by the way, Livingston High School is one of the, I think, top-rated public school systems in the entire country. So that was paper 1. Then in paper 2, we took all those molecular mechanisms, which are the gears, and we used cytosol to connect all this research together. Now remember, all of these molecular pathways are not something we made up. They're not a model. They're actually from many, in fact, 6,497 actual lab experiments that scientists have done across 184 institutions in 23 countries. So with this technology, we're able to take all this research, imagine them being 6,497 blind men, and connect them together, okay? So now when we connected all of this together, what we find is that in normal plants, we're able to show this, that formaldehyde is created and it's detoxified. And glutathione, that antioxidant, is beautifully maintained in normal plants. So basically, when you look at any time, if you pick a plant, it's always going to have some amount of background formaldehyde because some of it didn't get detoxified, okay? But the point is,
and isn't that like a waste product? It's just like a byproduct.
It's a waste product. It's a waste product, yeah. Okay? So the point is, when our final paper came out, some of these detractors who were trying to disinform people and confuse people, they said, oh, all plants have formaldehyde. Yeah, they do, but that's a background level, okay? But then in the normal case, plants create formaldehyde and they detoxify it. So that was paper number 2. We published in the American Journal of Plant Sciences, peer-reviewed journal. In paper number 3, we added another capability. So we had the formaldehyde detoxification pathway, part of C1 metabolism. Then what we did was we found out that plants also undergo stress. Just like you get stressed out if the weather changes or you have emotional stress or you stop eating. Well, plants undergo stress, for example, when the weather changes or when there's a drought. If there's a drought, a plant undergoes what's called oxidative stress. It thinks it's going to die. So what does it do? It's no longer in the normal mode. It goes into the oxidative stress mode. And in that case, the plant will use up its glutathione, which is that antioxidant because it's under oxidation. Glutathione levels will drop, and guess what happens? Formaldehyde will accumulate. Again, nothing to do with GMOs. This is a natural phenomenon that occurs when a plant is stressed out. That was paper number 3, which we also published in the American Journal of Plant Sciences. So we did paper 1, 2, and 3. Then in paper 4, which is, I believe, published in July, we asked an important question. We said, does genetic modification, and we focused it on soy, does genetic modification disturb the natural process of plants? And we felt systems biology could help. Remember, we'd done these 3 papers. So what we did was we said, we decided to take soy to be very specific. Remember, genetically modified soy is a number one genetically modified organism in the United States. 94% of all the soy we eat is genetically modified. So what we found was, again, we didn't make any of this up. We found another series of many papers where people had conducted laboratory experiments when they modified soy, did the genetic modification, what was called Roundup-ready soy. Remember, this is a Monsanto version where they create a version of soy which can resist their herbicide called glyphosate. So therefore, you need not only their pesticide, but you also need, they own both sides of the equation here. You also need their soybean. So Roundup-ready soy, which is a modified soybean, we found research when that soybean was modified that 5 different molecules were disturbed. They were not the same as a non-genetically modified soy. There were 4 enzymes. There were 4 enzymes and hydrogen peroxide. Okay, so this is independent of us. Independent research has shown 4 enzymes, proteins, get modified, disturbed in the genetically modified soy. Some of them are higher, some of them lower than in the non-genetically modified. So we took that result and we integrated it with the results of paper 1, 2, and 3. And what do we see? What we see, again, it's all integration. What we see is, we see that the plant believes it's under stress. So it uses up its glutathione, and guess what happens? Formaldehyde accumulates. So the same process when the plant thinks it's in a drought mode, is what that genetic modification is showing. So remember, again, we had integrated 6,497 wet lab experiments. We're not making this up. Across 184 institutions in 23 countries. From that integration, we see this dramatic growth, accumulation of formaldehyde. It's no longer detoxifying it, and this drop in glutathione. Well, in the fourth paper, we said, look, we're noticing this, and we're saying, and we concluded by saying, yes, we need to do more research to validate our findings. So we're very honest about it. And we furthermore said that should not glutathione and formaldehyde be used as objective criteria for determining the difference between a genetically modified food and a non-GMO? All right? So what we're saying is, forget nutritional content, fat, carbohydrate, blah, blah, blah. Why don't we use, maybe there are others, but definitely our researchers saying formaldehyde was very different in a GMO and a non-GMO, and glutathione was different. But Monsanto or others are not using them as criteria, when in fact they should be, because they're such important molecules. And when we concluded our paper, we said, look, if we can't, if we wanted to grow soybeans, the original non-GMO soybean and the GMO soybean, and we did the testing, in fact we validated our predictions, we would be attacked, because people would say, oh, what dirt did you use? You didn't use the right seed. Obviously, companies like Monsanto would likely attack us. And the reason they're able to attack us and protect themselves is there are no standards, right? So because if you have no rules, it's a Wild West. And the FDA has set it up so it is a Wild West. There are no standards, so anything goes. So what we have said was, to bound that problem, you must have standards. So what we're saying is we must have standards, which means if you're going to test a non-GMO GMO, because remember, material differences used as a basis of safety, that we need to have scientific standards. What's the soil you should use? Where should the seed come from? How long should the seed grow? How should you do the testing? So whether I do that testing, or Monsanto does that testing, or MIT does that testing, or Harvard does that testing, or any lab does the testing, or even high school students in Livingston, New Jersey, the results should always be the same, because you're following the same protocols. Because those protocols don't exist, things are being put out without any real testing. So based on that, we noticed that mainstream media wasn't even getting this out, because they were under the Kool-Aid of Monsanto, which, by the way, pays off a lot of PR companies, which came out. This is not a claim. We know this came out in the recent report in the New York Times. So we said, look, I'm willing to give away my $10 million building, because in the interest of the public, because I really wanted to make this important. I was willing to be dramatic about it. So I said, I'll give away my $10 million building if Monsanto can disprove my research that there are no safety assessment standards for GMOs. So if some of you, we didn't hire a PR agency. We went to a local newspaper called Patch.com. They posted it. Then it went viral on the internet. Eventually RT, Russian TV, which appears to in fact be more objective than our mainstream media, did an interview. And then in several of those media interviews, those including in Star Ledger, NewJersey.com, in RT, and they contacted Monsanto. And Monsanto first said they never heard about me, which is false, because in June they knew about my research because an NPR affiliate talked to them, and I have an email from June 21st from their director of PR. So they lied. And then they said, well, we just think this is a publicity stunt, but we'd like to meet with him. So if they do want to meet with us, we're meeting them halfway, and in Livingston, New Jersey on December 21st, where I went to high school, where I learned basic chemistry, where you need standards, with those high school students, with my colleague in my research, Dr. Ayyadurai, we are doing an open forum. We've sent an email to Monsanto, our executive director of our foundation our research foundation, inviting them to come, where we will go through all the 4 papers, and we'll ask them to disprove whether they're standards or not. So that's where we're at. So that's December 21st at 7 p.m. in Livingston High School. It's basically the $10 million Monsanto challenge is coming home, back to my hometown.
That is like so awesome. I can't wait to see how this all plays out. And as I'm listening to you talk, and I had went through your research, one of the things that came to mind is that I know that GMOs have not really held up during periods of drought. And I think that your research found that there was a connection there during that stressful time when, the formaldehyde was accumulating in the plant. And I'm thinking that there's a relationship there between the drought and the inability of the GMO to perform. It performed, not anywhere near as well as just the regular GMO soy or the GMO corn.
So we have another paper coming out in the series, which is basically showing the claim is that GMOs, the big lie is that GMOs is going to prevent, or
world
support
hunger,
the growing population which needs GMOs. Well, this is an absolute propaganda. The deputy director of the National Institute of Agriculture in India, Hema Yadav, has basically, this is a lie. It's propaganda. Countries like India, Africa don't need GMOs. They actually need, better irrigation. They need better tools. They need training. They need education. That's what they really need. There's more than enough arable land. In fact, India has taken an entire state in India and made it fully organic. So Monsanto has put this fear-mongering out there. Oh, the population is going to grow, therefore we need GMOs. And in fact, GMOs are more drought resistant. It's absolutely not true. We have a new paper coming out which is actually showing that GMO plants, because they need the glyphosate, actually the roots in those GMO plants are shorter, they're less efficient, they actually need more water. So let me repeat, we have data now showing that GMO plants at the molecular level need more water. So this again exposes the lie that GMOs actually help, can grow in drought conditions. And this is what's been used to promote these plants in countries like India and Africa. When in fact they're going to use more water, which means if they need more water, these developing nations are going to have to use more water, more irrigation to make sure the GMO crops operate.
Well, and it's not just the length of the roots, it's the microorganisms, it's the organic matter, and all of the other things that you find in a sustainable agriculture that helps to hold water in place longer, and the roots go deeper so that you're utilizing everything more efficiently. And I really like what Dr. Jonathan Foley says, that we need to not use more of the land on the planet for agriculture. Instead, we need to take what we're using now and have smarter agriculture, where we're doing a better job when the land that we have right now, instead of clearing more rainforest and taking up more land as the population continues to grow. And that's why I'm so excited about your research. I feel like there's so many areas here that we can utilize what you're able to do with taking this big picture look at everything. And as a dietitian, the idea of, I know that you haven't really taken into consideration the nutritional aspects as far as the differences between a GMO and a non-GMO. And to tell you the truth, I mean, when I look at some of the research that comes out trying to correlate nutrition and disease, I mean, how can you even trust any of that research when, just like you're trying to set up a system?
Well, what needs to happen, Elaine, is, you see, biology starting 2003 when the Genome Project ended, recognized we're not our genes, actually. You need to have a systems approach.
Right.
The ankle bone's connected to the foot bone, Things are not independent. They're interconnected. That is what systems biology is. The old biology was called biology. The new biology is called systems biology, which recognizes you have to interconnect things together. And that's what Cytosolve is. Cytosolve is a tool that lets us interconnect things together. We're not saying we're perfect, but what we are able to do is we've created a framework for interconnecting as scientific knowledge comes out. So it's not based on any one experiment or one person's, that we have to believe them. We're interconnecting it. So as more and more knowledge comes out, we'll interconnect. Now, if Monsanto has any data that they think refutes ours, we welcome taking their data and we'll integrate that in also. We're open. It's an open systems approach. So
I love that.
6,490. If they have another 100 experiments, we'd love to get it. We'd love to integrate it. So this is about transparency. Systems biology invokes transparency. It is not about one guy working in his back room publishing research that none of us ever get to see, that we have to just believe them. This is about integrating multiple sources of research. Well, and that's what we're finding. So the bottom line is, Monsanto has an opportunity here to get my 10 million bucks.
Yeah.
You know, or they have an opportunity to come out clean and say there is no standards for safety, that they should be stopped doing the false advertising saying that these things are safe, when the real bare truth is there is no standards for even assuming that. So we shouldn't even be putting GMOs out until, like in every other industry, we do safety assessment. Look, when X-rays came, when the X-ray technology came, it took people many years to realize that you better do shielding, you know, you better do lead. But that was after considerable research.
And people and the side effects that happen as a result of that. So what if I'd like to just take 1 minute here to go back and kind of the results that you guys have found where the formaldehyde is accumulating in the plant and the glutathione is dropping, which is the antioxidant that protects the plant. What do you see as like the long-term effects of that? I mean, what are the side effects of having plants that are doing that?
Well, we need to do research to do that. I can't say. What I'm saying is we have found a material difference. We have found that the GMO soy is not the same. That's what we can say. And we're saying we need to do more research. But we need to have standards. Where are the standards? Every other field of science has standards. The smoke alarm you bought has a standard before it could be put into your home. The car you bought has a standard that went through objective standards. Someone else has to inspect it, right? You and I don't inspect it. Someone else inspected the smoke alarm before you got it. Who, you know, before a drug goes out to market, it's got to go through the FDA, through clinical trials and approvals. And even in that case, which people are upset with, even in the case of pharmaceutical drugs, you can go to clinicaltrials.gov. It's transparent. You can see what tests were run, how many people were used in the trial. None of that is taking place with genetically modified organisms, particularly in the United States.
How can we help? How can consumers and people that are listening?
Well, what consumers need to understand is, you know, there's this big labeling thing, which is interesting, but labeling in many ways is simply telling people that there's GMOs there. But what I believe is going to happen is everyone is going to put, you know, even the pro-GMO industry in some ways is trying to support labeling. Now they're coming around because they're saying, okay, we'll put everything as GMO. So what? So when you go to shop, oh, okay, it's genetically modified. If that becomes a standard, then it's just going to be GMOs. The issue is these things should not even be allowed in the market because there's no safety standards. You might as well put skull and crossbones on everything if that's the labeling you need, because the reality is it has not been tested. There's been no standards for safety.
So we should stop even growing them.
What's that?
You're saying that we should stop growing them right now.
I'm saying this should never have been allowed, even by using basic discretion of, you know, the fact that there's no safety standards. I mean, you can't put anything on the road. I mean, you and I can't go create our own car company. We have to go through, get approved by, you know, the Transportation Authority. We have to go through a whole bunch of regulations. But anyone can create their GMO in their home. They just have to comply with the fact, just show that they're materially the same using their own criteria, and anyone can publish stuff out there. Put genetically modified foods out there. It's a Wild West. So this labeling stuff, frankly, in my view, it's an interesting movement. It's bringing out the fact what Monsanto's up to, but labeling is not the end-all and be-all. The reality is these things have not been tested. So what? You know this salmon is GMO. Well, they're going to be out there. How does labeling solve the because then we know those GMO salmon are eventually going to crossbreed with normal salmon, and then it's game, set, match. All salmon are going to be GMO.
That's upsetting.
Right. So the issue is these guys are very clever. And in fact, you have people, you know, who claim that they're for all of us. You know, like some of the Just Label It movement people. And in fact, some of them are owned by Dan One, which is one of the biggest, you know, pro-GMO, non-organic companies. And they're promoting labeling, in my opinion, not for the good reasons, but basically so they can just cover CYA, cover their ass. So the labeling issue is a symptom of something much deeper, which is that these things have not, in fact, the two main leaders who are running the labeling movement say that GMOs are not unsafe.
So, I mean, what did you think when you saw the results of your testing, and how do you eat? What kind of foods do you choose?
I mean, I try to eat. You know, first of all, I follow traditional diets. You know, which were indigenous people. You know, the Western civilization, which created the military-industrial complex, you know, killed many of my people. You know, I come from a low caste in India, indigenous people. You won't find a lot of Indians like me here, frankly, because I come from what's called a lower caste. My people, you know, I represent the indigenous people of India. My people lived off the land. They followed indigenous systems. They use all different ways to grow crops long before the white man came and colonialism came and said we needed all these things. These things were essentially neocolonial. GMOs are really neocolonialism. You know, when the colonialists came to India, they stopped the manufacturing of Indian textiles. They cut the thumbs off Indian textile workers and started manufacturing textiles in Manchester, England, and then imported them in. So this is the same model. You stop the manufacturing of traditional ways of doing agriculture, and then you force these darkies to import in the white man's genetically modified food. So this, in my view, is neocolonialism. Bill Gates is part of it. He's a neocolonialist. The Gates Foundation, Warren Buffett, all these guys, they think they're helping the dark people in Africa and India. And frankly, with
the rice that they have, the vitamin.
With all of it, they see us just as another couple of billion-dollar market, so they sell the lies that we need GMOs, that our indigenous methods were not successful when they were very successful. And then they create branding like the Green Revolution, right? It's all bullshit. So this is the same old long march of history where you have subjugation of majority of the people through promoting false narratives. In this case, a narrative is that the dark people and the poor white people, you know, there are these other elites who understand better, that we're going to tell you what's good for you. You need GMOs, you need pesticides, you need fertilizers, when for centuries people farmed that way very productively without any of that. So that's the deeper issue here. It's a small set of people controlling this for profit.
Well, and I get scared thinking about some of the other things that they're working on. It's like, you know, you give someone an inch and they take a mile. It's like I've heard of things called like CRISPRs and, you know, using the RNA.
CRISPRs is just a new technique. CRISPRs is just a new technique for doing genetic engineering, but in a very targeted way. But according to the Codex definition of genetic modification, that would still fall underneath that.
So does some of the things that you've learned through this whole process, I mean, does it like freak you out even more and more the more that you learn, and when you saw the results of your testing?
No, nothing. No. If you go under if one studies history and has the underlying systems view of how this system, which we call civilization, operates, you have to look at that as a system also. One will realize something very simple. Starting in the 1800s, we moved from feudalism to what's called today capitalism, which has evolved to what's called imperialism. And capitalism, as anyone knows, the goal is maximizing profit. So how do you maximize profit? You have revenue and you have expenses. So you have to minimize expenses and you have to maximize revenue. Revenue minus expenses equals profit. So how do you increase revenue? Where you expand into new markets. Okay, Africa, India, China.
And you control the market as well, right?
Right,
and then you reduce
and you reduce expenses, which means you do factory farming, you eliminate human labor. So that's what occurred in the United States. We have factory farms, we've eliminated human labor, we've consolidated into a few large factory farmers. So the idea is to maximize profit. Now we've sucked up all the value in the US, so we have to expand that same factory farming engine with Monsanto, with pesticides, with GMOs to other countries. So India, wow, that's a huge market. Let's go sell them and advertise the same nonsense, right? You need GMOs. We have better technology. American technologies go dot, dot, dot. So ultimately, this whole system's about maximizing profit. So if you follow the money, you realize where the truth is. And the truth is that it's about maximizing profit for a few people.
And so how should we feel as consumers about this system?
Well, I think as consumers, you have to understand where are the messages coming from? Who's telling you that GMOs are good? As a consumer, who can you trust? Well, you can't trust Hillary Clinton or the Democrats because Hillary Clinton and her husband's foundation are avid supporters of Monsanto. Okay? You can't trust the right wing or the left wing because they're basically mid-level management for a much bigger master. Who you can trust is your own intuition.
Right.
That's what you can trust because food is very intuitive. Your body knows what's right for you.
It's very personal. It's like
it's very personal, and it's very personal, and you can just look back 2 or 3 generations how your ancestors ate, and that's what we need to look at.
Yeah, I think people have lost that connection with food, and I really think that they know inside when they're eating some fast food hamburger that it's not doing anything for them. I don't even think they really enjoy it that much anymore. It's just kind of going through the motions where...
Well, the reality is poor folks, poor whites, poor blacks, poor Hispanics are the ones who eat most of the fast food. Okay? And then the rich people, I'm sure Hillary Clinton eats organic food. Okay?
I think so.
I venture to say most of the leadership of Monsanto's families eat organic food. So the wealthy people have preserved organic. I'm sure they eat non-GMO foods. We should go do some research. Versus the masses of poor people, they want to feed them GMO foods, inorganic foods, because they're basically machines that they want to use in their capitalist machinery. So poor people are fed crap. They're going to be told the crap that they're eating is okay. And that's how this process works,
So when everything comes down on the 21st, and everyone's meeting at 7:00 p.m. correct at the school over there in New Jersey, Livingston High School. What would you like to see happen when that event?
Well, look, we're doing it in a high school because this is like many other towns in the United States. We'll have families there, students there. It's in a public education. This is not a private school. It's another whole discussion, but this is a public school where I learned basic science, basic chemistry, basic rules of conduct and integrity. So we're bringing it back not to MIT, not to a major university. We're bringing it back to a hometown, which all of us live in local towns. And this research was partially done in that local town. And we're sharing with people in a local town. This is a local problem, and people in that local town can make decisions for themselves. And Monsanto is invited to get off their butts and get on their private jets or whatever they want and come to that local town. And if they're serious. And now likely they're not going to come because it's going to expose them, but they're welcome to come. And that's what needs to happen. We're making this very, very local. We don't want to make this big because the mainstream media will not likely cover this because it's not to their interest. Because if you look at the collusion among the 4 or 5 mainstream media, among the 4 or 5 the 2 major political parties, who they want their establishment candidates to be, and you make the connection between a few of the large farming, you see a very small group. They all hang out at the same parties. They're pretty incestuous, and they're all the same people. So they're never going to cover this. So it's alternative media that will cover this. And if they do cover it, they'll do it perhaps for ratings and to get some advertising revenue out of it.
Well, I would definitely be there. I wish I lived closer. I would show it for sure. I would love to talk to the people after they've heard the presentations. And I'm kind of curious because I actually work with high school students for 5 years myself, trying to get junk food out of schools. And I'm curious on what happened if you saw, I would think it would be exciting for you to be like a mentor to these students for one thing, and an inspiration to them with all you've accomplished in your life. But I'm curious on what kind of changes that you saw within the students that you worked with, and if that changed their perception of food.
Definitely. I mean, one of the things we did was, when I was in, I think, 9th grade, I read a famous essay by C.P. Snow called Two Cultures. C.P. Snow said that a scientist cannot just be a scientist. They also need to be a humanist, study the humanities. And the humanities people can't just be studying humanities. They need to study science. So what was valuable for these students, and why the high school is very happy that I'm coming back there, is that here's the students who did a scientific research project, but they're also learning the power of their science and its effects on social policy. Rarely do students get to see that interconnection. Mm-hmm. These 4 students, I believe it's going to change their lives, because they're seeing what they do in the lab, what they do in science, literally is affecting what goes on, that their scientific research can have impact. Right?
I think that's so exciting. Yeah, I love that.
As a scientist, you have the noble duty to tell the truth. That is what science is. But most scientists don't see that anymore. The NIH funding in this country has been cut. So if you're an associate professor and you want to get tenure, you can't even get good funding, so you have to take money from wherever you can. So in some ways, you become a slave to the money. And that's how this all goes. And it's unfortunate, So the opportunity for students who are untainted is they're doing this research. They don't know anything. Fortunately, they have their parents funding them. So it's a good opportunity for students, to learn this.
Well, I worked with students to try to change nutrition policy at their school, and we actually changed nutrition policy at every school in the country by what we did in California. And I'm always curious to wonder, because I took those kids to an organic farm, so they got to actually be at a farm and eat organic food. And I would love to connect with them now, because 10 years have passed and they have their own kids. And I wonder, as much as they resisted me, getting them to not drink soda and that kind of thing, I wonder if that really did impact them as far as how they raise their children and the kind of foods that they fed them, if I got through or not. And,
right.
And I'm wondering, if, because you're talking about policy change, and that's what we were trying to accomplish at that high school, is change policy of what kind of foods were offered to the students. And it was pretty upsetting when I'd see hot Cheetos and soda being eaten as a standard for lunch. I'm wondering, are these kids, after what they've learned about the GMOs, have they had any interest in changing their nutrition policy at their school?
Yeah, definitely. I think what's happened is these students are quite smart. They understand that. They also understand at a more deeper level. One is, fine, I'm going to change what I eat. That's important. But one is deeper, understanding how this whole system operates. How capital works. Who's controlling decision-making. This is the important issue.
Well, I think...
and become communicators of this. A wise man once said, it's not what you put inside your mouth, it's what comes out of it.
Oh, I love that.
So what are you communicating? There are a lot of very wealthy people who watch what they put in their mouth, okay? But they're exploiters. They misuse their power. They could be eating organic food all day. But, what do they tell other people, They manipulate money. They exploit labor. So it's what you do, Obviously eating well and being aware is important, but it's what you serve and how you communicate this to the rest of the world.
Well, I'm excited about how this, what kind of changes can happen as a result of this. But I have to tell you that what you have done with these kids, to me, it just really kind of touches my heart, because this is what I try to communicate to people all the time. First of all, as parents, as adults, we have to lead by example. We have to show our kids that we don't have to just take, just like you were explaining to us and educating us on today, that we don't have to just take what's being told to us or what's being put in front of us, that we can choose ourselves what we eat. And I love the fact that you're teaching these kids how to fight and that they can change policy.
Exactly.
That, to me, is the most powerful message that we could get across to our young people, is that you don't have to just take what people are trying to force you to do, that you can be an individual, you can make your own decisions, you can change policy, you know, if you want to, if you put the effort. And I just think it's just such a powerful message, and I just want to thank you.
Sure, you're welcome.
You're really kind of getting to me right now. just the thought of all this, because I know how it can change, and I hope that those kids get an opportunity to really share what this whole experience.
You know, it's time that's the noble duty of what science was about be done. I mean, scientists are frankly useless. A carpenter, you know, is supposed to build something. You know, a nurse, you know, helps, you know, people with healthcare, right? A scientist has one duty: to tell the truth. They're supposed to explore the truth and share the truth as well as they know it, even in the midst of uncertainties. But you know, what we have now is a corporatization of science and the subjugation of scientists. So it's really up to scientists to have the courage to speak out and not be part of something that could be very, very deleterious, because scientists are the ones that the rest of society relies on. So anyway, thank you, Elaine, for having me on the show.
Well, thank you. I'm going to get this out to as many people as I can, because I think we have a really important message here, and I wish you luck. And I'm going to be I'm going to be checking back. I can't wait to hear what happens. So if they show up or not, but I think you've definitely started something that's going to have an impact, a lot of change. All right. Bye-bye.
Thank you.
All right. Bye-bye. Take care.